Fine. Let's start. Number 10. WT1190F. On the 3rd of October, 2015, a telescope in Arizona spotted something moving through the dark near Earth, and nobody could tell you what it was. It was small, maybe 1 to 2 meters across. It was looping around our planet on a long, stretched-out orbit that carried it almost twice as far out as the Moon, and then back again. And when astronomers pulled up their catalogues to figure out which known object this was, they came up empty. It matched nothing. It had a temporary designation, WT1190F, and if you say those last letters out loud in the right order, you'll understand the mood in the room. Astronomers had a quiet nickname for it. They called it WTF. Here's what made it strange. Most things we track near Earth are either natural rocks or satellites we put there on purpose with paperwork. This thing had no paperwork. It had been glimpsed once, briefly, in an image from 2009, and then it vanished from the record for 6 years. When they finally worked out its density, the number came back absurdly low. Whatever it was mostly empty inside. Hollow. So for a few weeks in 2015, we had orbiting our own planet, an unidentified, hollow object of unknown origin that we could not connect to any mission any nation had ever flown. And then we watched it die. On the 13th of November, 2015, WT1990F came screaming into the atmosphere over the Indian Ocean, just south of Sri Lanka, and burned up in a streak of fire that scientists had predicted almost to the minute. It was the first time in history we ever called the fall of a piece of space debris that precisely. Because that's what it turned out to be. Debris. Almost certainly a spent rocket body from some old mission to the Moon or beyond. A hollow metal casing that had been drifting in the dark for decades. Made by intelligence? Yes. Just, probably, our own. But sit with the shape of that story for a second. We found an artificial object in space. We could not identify it. We could not name the mission that made it. And to this day, with all our records, nobody can tell you for certain which rocket it came from. We built the thing, lost track of it, and rediscovered it as a mystery. That's the uncomfortable little door this whole video walks through. Because if we can lose our own hardware in the dark and mistake it for a natural object, even briefly, then the reverse question becomes fair game. How confident are we, really, that everything out there is natural? And for one object that fell over the Indian Ocean, the honest answer was not confident at all. Number 9. 1991 VG. On the 6th of November, 1991, an astronomer named James Scotty was working the Spacewatch telescope on Kitt Peak in Arizona when he found a small, faint object moving against the stars. Routine, at first. Another little near-Earth rock in a sky full of them. Then they worked out its orbit, and the routine feeling went away. Because 1991 VG wasn't on some wild, tilted, obviously natural path. It was on an orbit almost identical to Earth's. Same kind of distance from the Sun. Same kind of shape. It circled the Sun in a way so similar to our own planet that it behaved almost like a second, temporary companion, drifting near us and then away again. A month after it was found, it slid past Earth at just over 1 lunar distance. Cosmically speaking, that's a whisper away. And that Earth-like orbit is exactly the problem. Natural asteroids tend to come at us from all angles, on paths shaped by billions of years of gravitational shoving. An object that just happens to be pacing our own planet, matching our lap around the Sun, is rare enough to raise an eyebrow. It's the kind of orbit you'd choose if you wanted to sit quietly near Earth and watch. An astronomer named Duncan Steele noticed exactly that. Steele is a serious scientist, a specialist in small bodies in the solar system, and in the mid-1990s, he did something most scientists are far too cautious to do. He put the idea in print. He suggested, very tentatively, that 1991 VG might be artificial, not a rock, a probe, possibly even a self-replicating one, the kind the mathematician John von Neumann imagined, a machine sent out to explore and copy itself across the galaxy. In the absence of any better explanation, Steele wrote, it was at least a candidate worth considering. Think about how strange it is to see that sentence in a scientific paper. Not aliens are here. Just, here is an object. Here is its oddly deliberate orbit, and I cannot fully rule out that somebody sent it. The object then did something almost theatrical. It disappeared. After 1992, 1991, VG went unseen for 25 years. And then, right on schedule, as predicted, it came back. In May of 2017, a telescope in Chile recovered it, exactly where the orbital math said it would be. By then, we knew more. We had better models of how tiny asteroids tumble and behave, and 1991, VG fit them. It spins fast, the way small natural rocks of its size do. The consensus today is that it's a genuine asteroid, an ordinary if unusually Earth-like piece of the solar system. Probably. That's the word that keeps following these objects around. Probably a rock. But for a while, a real astronomer looked at its orbit and wrote down the other possibility, and the sky gave him no reason to take it back for 25 years. Number 8. HD 139139. Let's talk about a star that flickers like it's sending code, except nobody can find the code. The star is called HD 139139. When the Kepler Space Telescope, in its extended mission, stared at it for about 87 days, it caught the star's brightness dropping in little dips. 28 of them. A tiny fraction of the star's light, blocked for a moment, over and over. Now, dips like that are the bread and butter of planet hunting. When a planet passes in front of its star, it blocks a sliver of light, and it does it on a schedule. Every orbit, same interval, like clockwork. That regularity is the whole point. It's how we've found thousands of worlds. You see a dip, then the same dip a set number of days later, and you know something is going around. HD 139139 broke the clock. The 28 dips came at random. No steady rhythm. No neat interval you could set your watch by. The astronomers who studied it, led by Saul Rappaport, put it about as bluntly as scientists ever do. They said the arrival times of these dips could just as well have been produced by a random number generator. That is a deeply weird thing for a star to do. Because random is hard. Nature loves patterns, orbits, resonances, cycles. Randomness in the timing of transits shouldn't happen if it's just planets going around, because orbits are periodic by definition. So the team went down the list of every natural thing that could cause it. Lots of planets at once, planets shedding dust, wild variations in orbital timing, two stars tangled in a binary, a swarm of asteroids, a jittery, spotty star surface. One after another, they tested the ideas, and one after another, none of them cleanly fit. They didn't claim aliens. Good scientists almost never do. But when you have a star dropping in brightness at intervals that look like they came out of a lottery machine, and you've ruled out the ordinary suspects, you're left holding a genuine mystery. Something crossed in front of that star, again and again, with no rhythm we could name. There's a quieter footnote here, and it cuts the other way. A few years later, a sharper telescope called Cheops went back to look at HD 139139, watching for the same random dips. And it didn't see them. Whatever was happening seems to have stopped, or was never a permanent feature to begin with. So which is more unsettling? A star that flickers at random forever, or a star that flickered at random for 87 days, refused every explanation we offered, and then went quiet, like it was never there at all? Number 7. VVV WIT 08. Somewhere toward the center of our galaxy, about 25,000 light years away, there's a star roughly 100 times the size of our sun, a true giant. And a little over a decade ago, something reached across space and almost switched it off. Astronomers watching a survey of the galactic bulge caught this giant star fading. Not flickering, not a quick blink, but a long, deep, deliberate dimming that went on for a few hundred days. At the bottom, around April of 2012, the star had lost 97% of its light. It nearly disappeared. And then, just as slowly, it climbed back to normal, as if nothing had happened. They named it VVVV WIT 08. The WIT part is the tell. It stands for, what is this? A label astronomers slap on objects that don't fit any known category. When the professionals name something, what is this? You know you found the interesting stuff. Here's why it's so hard to explain. To dim a star that enormous by 97%, you need something huge to pass in front of it. Not a planet-sized speck. Something on a scale that can blot out most of a giant. And the way it dimmed carried its own clue. When ordinary dust passes in front of a star, it filters the light unevenly, killing some colors more than others, the way a dusty sunset turns red. This didn't do that. Not cleanly. The dimming was close to colorless. Whatever slid across the face of that star was large, and it was opaque, and it dropped the light almost evenly across the spectrum. The leading natural explanation is that there's some unseen companion out there, a smaller star or a planet, dragging along a vast disk of dark material, and that disk swept across the giant like a hand passing over a lamp. That's plausible. It might even be right. But the researchers themselves admitted that none of the explanations were a fully satisfying match to all the data, and that the event's secret hasn't really been solved. And of course, once you say the words, something enormous and opaque passed in front of a star, and we can't fully explain it, the imagination goes where it goes. This is the exact profile people invoke when they talk about hypothetical megastructures. Vast objects built around stars. Nobody serious is claiming that's what VVV WIT 08 is. But the shape of the mystery, a giant star, an enormous unseen object, a near total eclipse we can't cleanly account for, is enough to make you look twice. A star 100 times the size of the sun went dark, almost completely, and then came back. And the truth is, we're still not entirely sure what got in the way. Number 6. The vanishing stars. Stars are supposed to be the reliable part of the sky. They're the fixed points, the ones sailors trusted, the ones that outlast empires. So what do you do when you compare old photographs of the sky to new ones, and some of the stars are simply gone? That's the question behind a project with a long name and a short obsession. It's called VASCO, the Vanishing and Appearing Sources during a Century of Observations, led by an astronomer named Beatriz Villarroel. The idea is beautifully simple. We have photographic plates of the night sky going back to the 1950s. We have modern digital surveys of the same sky. Lay them side by side. Anything that was a clear point of light back then and is nowhere to be found now gets flagged. And they found about 100 of them. Points of light sitting in the old plates from the 1950s, 60s, and 70s that don't appear in any modern image. Stars, apparently, that were there and then weren't. Now, stars don't usually just vanish. That's the whole point. When a big star dies, it doesn't quietly wink out. It explodes as a supernova, one of the brightest events in the universe, and it leaves a wreck behind, a glowing remnant you can still see. A star that simply disappears, cleanly, with no explosion and no leftover glow, is not something our physics has an easy slot for. It's not supposed to happen. Villarroel has been careful, But she has also been honest about how far the question goes. The project was designed, from the start, to search for genuinely vanishing objects, things that disappear without leaving a trace, and she has openly kept exotic explanations on the table, including the possibility of technosignatures. Signs, in other words, of technology. And there's a detail that makes people lean in. Some of the strangest transients, brief points of light that appeared and disappeared, show up on plates from before 1957, before Sputnik, before there was a single human-made satellite up there to catch the sunlight and cause a glint. So whatever those flashes were, they weren't reflections off our own hardware, because our hardware didn't exist yet. Here's the honest other side. The most likely explanations are stubbornly boring. Old photographic plates are delicate. A speck of dust, a scratch, a chemical flaw in the emulsion can all leave a mark that looks exactly like a star. Some candidates are probably variable stars caught at a bright moment, or fast-moving objects that simply drifted out of frame. After tracing hundreds of millions of sources, the project has not confirmed a single, definite star that vanished without a trace. But it hasn't ruled it out either. And that's the strange, itchy place Vasco leaves you. Somewhere in 100 old points of light, there might be nothing but dust on glass. Or there might be one real star that was there when your grandparents were young, and is gone now, and never told us why. Number 5. Project Hephaestus. Back in the 1960s, a physicist named Freeman Dyson floated an idea that has haunted science ever since. If a civilization gets advanced enough, and hungry enough for energy, the logical thing to do is stop letting your star's power leak uselessly into space. You build. You surround your star with a vast swarm of structures, panels, habitats, collectors, and you catch its energy. We call it a Dyson sphere. And Dyson pointed out something clever. A structure like that would give itself away. All that captured starlight has to go somewhere. As the megastructure absorbs the star's energy and warms up, it would glow, not in visible light, but in the infrared, in heat. So if you want to hunt for alien civilizations, you don't necessarily listen for radio. You look for stars that are strangely warm in the infrared, stars wearing a coat of waste heat they shouldn't have. For decades, that was mostly a thought experiment. Then, in 2024, a team running something called Project Hephaestus actually went looking. They took data on about 5 million stars, combining 3 great surveys of the sky, the Gaia mission, and the infrared surveys known as 2MASS and WISE. They built a careful pipeline, even using a neural network, to sift through all those stars and find the ones with an odd infrared excess, extra heat with no ordinary explanation. They filtered hard, trying to throw out everything that could fake the signal. And they came out the other end holding 7 candidates. 7 stars, all of a type called M-dwarfs, small red stars, each glowing with more infrared than it should, in a way the team said was consistent with a simple Dyson sphere model. Not proof. The researchers were clear about that. But 7 real stars, named and cataloged, that passed the first test for being wrapped in something that's harvesting their light. Let that sink in, because it's different from the other objects on this list. This wasn't one weird star somebody stumbled on. This was a deliberate, systematic search of millions of stars for the fingerprint of an engineered structure, and it didn't come back empty. It came back with a short list of suspects. Now, science being science, the follow-up has been brutal. Other researchers looked at those 7 and argued that at least some, maybe all of them, are being contaminated by something in the background. Distant galaxies choked with dust, sitting behind the stars and leaking infrared that muddies the signal. In that reading, the waste heat isn't a megastructure at all. It's a faraway galaxy photobombing the data. That might well be the answer. But notice what it means. We now have the tools to survey millions of stars and pick out the ones that look, at first glance, like somebody built something around them. The search has left the realm of thought experiment. There are 7 names on a list, and every one of them is a star we can point a bigger telescope at and ask directly, is anybody home? Number 4. Phobos. Everything so far has been light years away, comfortably distant. Let's bring the mystery closer. Let's bring it to Mars. Mars has 2 little moons, and the inner one is called Phobos. It's small, lumpy, potato-shaped, scarred with craters, and it orbits so close to Mars that it whips around the planet 3 times a day, faster than Mars itself rotates. From the Martian surface, Phobos rises in the west and sets in the east, which is already a little wrong feeling. But that's not the strange part. The strange part is the density. Back in the 1960s, the Soviet astrophysicist Iosif Shklovsky studied the way Phobos moves, the way its orbit seemed to be slowly spiraling inward, and he calculated something startling. To be dragged in the way it appeared to be, Phobos would have to be extraordinarily light for its size. So light, he argued, that it couldn't be solid rock. It would have to be, in his words, essentially hollow, like an empty tin can. And Shklovsky followed that thought to its unnerving conclusion. A natural moon isn't hollow, but something built might be. He suggested Phobos could be artificial, a vast hollow shell placed in orbit around Mars by someone. Now, this is the part where people expect me to say a lone crackpot floated a wild idea. But that's not what happened. Shklovsky was a respected scientist. Carl Sagan, yes, that Carl Sagan, took the idea seriously enough to co-write a whole book with him, Intelligent Life in the Universe, in 1966. Another scientific advisor of the era wrote that if the moon really was spiraling in the way the observations suggested, there was little alternative to the conclusion that it was hollow, and therefore made. For a brief window, the hollow moon hypothesis wasn't fringe. It was a live scientific question about an object in our own solar system. And it gets one more layer. On the surface of Phobos, there's a feature that has been photographed and nicknamed the monolith. It's a big boulder, around 90 meters tall, standing more or less alone, casting a long shadow across the moon's surface. Buzz Aldrin, the second human being to walk on the moon, has talked about it out loud more than once. We should visit the moon of Mars, he said. There's a monolith there, a very unusual structure on this little potato-shaped object. So what's the truth? The modern answer is less dramatic, but not nothing. Phobos really is low in density, but we now think that's because it's porous, a loosely packed rubble pile full of empty gaps and voids, rather than a manufactured shell. The monolith is almost certainly a natural boulder, thrown up by an impact, standing where it landed. No aliens required. But here's the thing that lingers. Multiple spacecraft sent to study Phobos up close have failed. The Soviet Phobos 1 and Phobos 2 missions both died on the way, one falling silent, the other going dark just as it reached the moon. Decades later, another mission aimed at Phobos failed before it ever left Earth orbit. It's coincidence. Space is hard, and missions fail all the time. But there's a small, superstitious corner of the mind that notices when a strange little moon keeps swallowing the machines we send to look at it. Number 3, the interstellar meteor. Almost everything on this list is something we watched from a distance. This one is different. This is the object somebody physically went out into the ocean to touch. The story starts on the 8th of January, 2014, with a fireball. A small meteor, less than half a meter across, streaked into the atmosphere and burned up over the Pacific, near the coast of Papua New Guinea. On its own, that's nothing special. Meteors hit our atmosphere constantly. But years later, 2 astronomers, Amir Siraj and Avi Loeb of Harvard went back through the data on this particular fireball and noticed its speed. It was moving too fast, on the wrong kind of path, to have come from inside our solar system. If they were right, it meant this little rock had come from somewhere else, from another star. It would be an interstellar object, a piece of matter that had drifted across the empty gulf between suns and ended its journey by slamming into Earth. And in 2022, the U.S. Space Command actually weighed in, confirming that the object's velocity supported the interstellar interpretation. They labeled it IM-1, Interstellar Meteor 1. Now here's where most stories would end. A fireball, a fast one, probably from another star, burned up years ago. Case closed, but Avi Loeb is not most scientists, and he asked a question almost nobody asks. If pieces of that object survived and fell into the ocean, could we go and get them? So he did. In June of 2023, Loeb led an expedition out to the stretch of Pacific seafloor where IM-1 was calculated to have come down. They dragged a sled covered in powerful magnets back and forth across the ocean bottom, trawling for whatever the fireball had left behind. And they came back with something. Around 850 tiny metallic spheres, spherules, each smaller than a grain of sand, pulled up from the dark. Then came the analysis, and the real claim. When Loeb's team studied the composition of those spherules, they reported that roughly a fifth of them didn't match the ordinary chemistry of our solar system. Some had an unusual pattern of elements that Loeb argued pointed to an origin outside the Sun's family entirely, and possibly, he suggested, to something manufactured. I want to be very fair here, because this is contested ground. A lot of scientists think Loeb is wrong. Critics have argued that the iron isotopes in those spherules actually point firmly back to our own solar system, with overwhelming statistical confidence. Others question whether the little spheres are even related to the fireball at all, or whether they're just ordinary droplets that rain down onto the seafloor from all sorts of sources. NASA and many astronomers remain deeply skeptical that IM-1 was interstellar in the first place. But strip away the argument for a second and look at what actually happened. A scientist believed a rock from another star had fallen into our ocean, so he chartered a boat, went out to the exact spot, dragged the seafloor, and pulled up a bag of metallic beads to test in a lab. Whatever the final verdict, that's extraordinary. For the first time, the question of alien material stopped being a thing we only argue about, and became a thing somebody could hold in a gloved hand and put under a microscope. Number 2. Przybylski's star. There's a star about 310 light-years away that chemically should not exist. When you break its light apart and read what it's made of, you find something that stops astronomers cold. Because this star appears to contain elements that, by every rule we know, should have vanished long ago. The star is called Przybylski's star, after the Polish-Australian astronomer Antoni Przybylski, who first studied it back in 1960. From the beginning, it was obviously odd. It's a peculiar star, the kind we literally file under the letter P for peculiar, with a chemical fingerprint unlike almost anything else in the sky. But the deeper people looked, the stranger it got. Because in the atmosphere of this star, spectroscopists have reported the signatures of the heavy radioactive elements, the actinides. We're talking about actinium, protactinium, neptunium, plutonium, americium, curium, and on up the periodic table, all the way to Einsteinium. Some studies have also flagged promethium and technetium. Here's why that's a problem. These elements are radioactive, and many of the relevant isotopes have short half-lives, on the scale of years, decades, thousands of years. Cosmically, that's the blink of an eye. Elements like that don't just sit around in a stable old star for millions of years. They decay. They should be long gone. Finding them fresh in a star's atmosphere is like walking into an abandoned house that's been empty for centuries and finding an ice cube that hasn't melted. Something had to have put it there recently, or something has to keep making it. So what's going on? There are natural ideas, and they're genuinely fascinating in their own right. One is that these elements are the decay products of undiscovered, super heavy elements from what physicists call the island of stability. Hypothetical atoms far heavier than anything on our periodic table. Elements we've never made and never found, quietly falling apart inside this star and leaving these radioactive fingerprints behind. If that's true, Przybylski's star is showing us chemistry we don't even have names for yet. And then there's the other idea, the one that gets whispered. Some have suggested that a star this saturated with fresh radioactive material might not be doing it on its own. That perhaps an advanced civilization is using the star deliberately as a place to synthesize or dispose of radioactive elements, dumping nuclear waste into a furnace so enormous that it makes our entire concept of waste management look like children playing in sand. A star as an incinerator. A star as a landfill. I'm not telling you that's the answer. It almost certainly isn't. The natural explanations, weird as they are where most astronomers put their money. But that's what makes Przybylski's star so haunting. Even the boring explanation involves elements humanity has never seen. And the exciting explanation involves someone out there, 300 light years away, tending a fire in the dark for reasons we can't begin to guess. Number 1. 3I Atlas. Everything else on this list happened in the past. This one is happening right now. As you watch this, there is an object moving through our solar system that did not come from here. And a Harvard astronomer has asked, out loud, in a real scientific paper, whether it might be a piece of technology. On the 1st of July, 2025, a survey telescope in Chile, part of a system called Atlas, picked up something faint and fast. Very fast. As astronomers tracked it and worked out its path, the numbers told an unmistakable story. This object was not orbiting the sun in a closed loop like a planet or a comet native to our system. It was on an open, unbound trajectory, tearing through on a one-way visit, moving at something like 57 kilometers every second. It had come from interstellar space, and it was headed back out into it. It became only the third interstellar object we have ever confirmed. The first was Oumuamua, back in 2017, that strange elongated thing that accelerated as it left and started a decade of argument. The second was Comet Borisov, and now this, the third, given the name 3I Atlas. The 3 for third interstellar object. Most astronomers looked at 3I Atlas and saw a comet, an ancient chunk of ice and rock from another star system, wandering the galaxy for who knows how many billions of years before threading through our little corner of it. That's the consensus, and it's built on real observations, from Hubble, from ground telescopes, from careful spectroscopy of the light it gives off. But one scientist wasn't ready to close the book. Avi Loeb, the same Harvard astronomer from the ocean expedition, looked at 3I Atlas and started listing the things that bothered him. He pointed to unusual features, a jet of material that seemed to point toward the sun rather than away, which is not how comet tails are supposed to behave. Odd properties in how its light was polarized. And he did something that makes his colleagues wince and the rest of us lean in. He wrote a paper, and he titled it plainly, "Is the Interstellar Object 3I Atlas Alien Technology?" Loeb even has a scale for this, a ranking from 0 to 10, where 0 is a perfectly ordinary natural comet and 10 is alien technology that poses a genuine threat. He gave 3I Atlas a 4, not a dismissal, not an alarm, a 4, an object interesting enough to keep both eyes on. And so we did the obvious thing. We listened. Radio astronomers turned their instruments toward it. Breakthrough. Listen at the Green Bank Telescope, the Allen Telescope Array, scanning 3I Atlas for any hint of a transmission, any narrow band radio whisper that would betray a machine. And they heard nothing. No signal. No beacon. Silence. The overwhelming weight of the evidence says 3I Atlas is a comet, a natural traveler, beautiful and ordinary, in the way that only something from another star can be ordinary. That's almost certainly what it is. But step back and look at what this object really represents. Because this is bigger than one rock. For all of human history, the stars were untouchable. They were pictures on the ceiling of the world. And now, 3 times in less than a decade, physical pieces of other star systems have come coasting through our own, close enough to study, close enough to argue about, close enough that a serious scientist can point at one and ask whether somebody made it. We have gone from a species that could only look to a species that has visitors. And here's the thought I want to leave you with. Every object in this video, the debris we couldn't name, the rock on the perfect orbit, the star that flickered like code, the giant that blinked, the stars that vanished, the 7 stars glowing with impossible heat, the hollow moon, the beads from the seafloor, the star full of elements that shouldn't exist, and this visitor passing through tonight, every single one almost certainly has a natural explanation. Almost. The universe, so far, keeps handing us the ordinary answer. But it only has to be extraordinary once. One vanished star that didn't just fade. One spheral that really came from a ship. One comet that turns, gently, against the sun, and doesn't stop. We have spent our whole existence assuming the sky is empty of intent, that everything up there is just physics, just rock and gas and light. And maybe it is, but we are finally close enough to check, and the checking has only just begun. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.